What if I told you that the greatest obstacle between humans and Mars was never distance, never courage, and never even money, but time itself? Because for decades, Mars has felt close enough to dream about, yet far enough to remain unreachable. A red dot in the sky, promising a future that always seemed just out of reach. And now suddenly NASA and MIT are saying something that sounds almost impossible. That humans could reach Mars in nearly half the time we once believed was unavoidable. Not through science fiction, not through fantasy engines, but through a very real, very dangerous, and very powerful idea humanity once feared so much that we banned it from space entirely. Nuclear propulsion. And this is where the story truly begins. Because the moment you hear the word nuclear, your mind jumps to disasters, weapons, and uncontrollable power. Yet what NASA and MIT are quietly reviving is not a bomb, but a controlled force so efficient that it could completely rewrite the rules of space travel. And the shocking truth is that this technology is not new. It was first seriously tested during the Cold War, when the same fear that pushed humanity to the edge of annihilation also pushed science forward at unimaginable speed. Because back then, the United States realized something terrifying. Chemical rockets were simply not good enough for deep space. They were slow, inefficient, and fragile. And if humanity ever wanted to go beyond the moon, it would need a propulsion system that didn't burn fuel the way a candle burns wax, but instead released energy at an atomic level. And that realization gave birth to nuclear thermal propulsion, an engine concept that heats hydrogen using a nuclear reactor and blasts it out of a nozzle at speeds chemical rockets can't even approach, producing thrust with dramatically higher efficiency, meaning spacecraft could go faster while carrying less fuel. And this is the first major reveal. Nuclear rockets don't just make space travel faster, they make missions fundamentally safer, because time and space is the real enemy. Radiation exposure, muscle loss, bone decay, psychological stress, and equipment failure all increase the longer humans are trapped between planets. And if a Mars mission takes 9 months, one way, astronauts are slowly being damaged before they even arrive. But cut that journey down to 4 or 5 months, and suddenly Mars stops being a suicide mission. It starts looking like a survivable expedition. And this is why NASA and MIT's new nuclear rocket concept is sending shockwaves through the scientific community. Because it doesn't just promise speed, it promises survival. And yet, despite its potential, nuclear propulsion was abandoned decades ago. Not because it didn't work, but because politics, fear, and public perception made it untouchable. Treaties banned nuclear explosions in space, budgets shifted, and humanity chose the safer image over the more powerful solution. And for years, Mars remained a dream postponed by fear, until now, because something has changed, not just in technology, but in urgency. This is the second major reveal. The reason nuclear rockets are returning is not curiosity, it's necessity. Because modern missions have revealed a brutal truth. Mars is far more hostile than we expected. Radiation levels are higher, dust storms last longer, and resupply missions from Earth are impractical, meaning any human mission must be fast, efficient, and resilient. And chemical rockets simply cannot meet those demands without enormous risk. And this is where MIT enters the story. Because while NASA provides mission experience, MIT provides something equally critical: extreme innovation, advanced materials, reactor miniaturization, and simulation models that allow nuclear reactors to be built smaller, lighter, and safer than ever before. And together they are working on next-generation nuclear thermal propulsion systems designed to operate in space without ever detonating, without spreading radiation, and without threatening Earth. Because the reactor remains inactive until the spacecraft is already in orbit, far from the atmosphere. And here comes the emotional twist. The same energy that once terrified humanity might now be the key to protecting astronauts' lives. Because faster travel means less radiation exposure, fewer system failures, and a greater chance of returning home alive. And yet, despite this promise, the technology still faces enormous challenges. Political resistance, public fear, and engineering limits that push materials to their absolute breaking point. Because nuclear reactors operate at extreme temperatures, and hydrogen, while efficient, is notoriously difficult to contain. And this leads us to the third major reveal. NASA and MIT are not just building an engine, they are building a compromise between power and control. between ambition and responsibility, because this nuclear rocket is not designed to conquer space. It is designed to coexist with it, to move through it efficiently without contaminating it. And that balance is incredibly hard to achieve. And yet if they succeed, the implications extend far beyond Mars. Because a successful nuclear propulsion system could open the outer solar system to human exploration, making missions to Jupiter, Saturn, and even beyond possible within a human lifetime. And this is where the story becomes deeply human. Because for the first time since Apollo, humanity stands at the edge of becoming a multi-planet species. Not in theory, but in practice. And the real question is not whether the technology will work, but whether humanity is ready to trust itself with that kind of power again. Because nuclear energy has always reflected our intentions. When driven by fear, it became a weapon. But when guided by purpose, it could become a bridge between worlds. And this is the lesson hidden inside NASA and MIT's nuclear rocket project. That progress is not about inventing new power, but about learning how to use old power wisely. And as this engine moves from simulation to testing to reality, one truth becomes impossible to ignore. The distance between Earth and Mars has never been the real barrier. The real barrier was our hesitation to embrace the tools that could take us there safely. And now that hesitation is fading, because the future is demanding speed, resilience, and courage. And when the first humans finally step onto Martian soil after a journey half as long as anyone thought possible, history will remember this moment not as the day we built a faster rocket, but as the day we finally learned to balance power with responsibility. And the cliffhanger is this: if nuclear propulsion can take us to Mars, what happens when it takes us beyond it? And are we prepared for the kind of universe that opens up when distance is no longer the limit? So if this story made you rethink humanity's future in space, comment your thoughts below, like this video to support science storytelling, and subscribe to AEDID, because the next giant leap may already be underway.